Now in this part then we're told that the two lines intersect, and we've got to find the value then of P. So what does this mean? We'll also notice that I've now added to the diagram, I've added the position vectors, the red R and the blue R. Remember that R represents any point on the line, so if I vary lambda, this point here will move up and down this line. And again, if I vary the value of mu, this point will move up and down this line. So there comes a point, this point here, where both these two position vectors, the red one is exactly the same as the blue one. That point will be when both R's are pointing at this point here. Now when you've got two lines intersecting then, and these two are exactly the same, we can say that the point of intersection, this vector here, must equal this vector. I'll show you. Okay, there you go. Given that L1 and L2 intersect, then we've got the red vector must equal the blue vector. Now how do we go about finding P then from here? Well, when two vectors are equal to one another, we can compare the components. So in other words, if I compare the I components, and we should tell the reader that that's what we're doing, so we'll just have a look at the I components. That means that the top line, the I components, must be equal. So in other words, 11 minus 2 lambda, okay, let's just put that down, must equal minus 5 minus 3 mu. So we've got minus 5 minus 3 mu. So that's the I components, and if we rearrange this, say add 5 to both sides, we therefore have 16, and suppose we add 2 lambda to the other side, we get 2 lambda minus 3 mu. Okay, now we can't solve this because we've got two unknowns, lambda and mu, in the same equation. So let's just number this equation number 1, say. Now what we do next is we look at the J components, that's the middle line through here, and we do exactly the same. Let's compare the J components. So if we do that, J components, what do we get? Okay, well we've got 2 plus lambda, so I put that down, 2 plus lambda is equal to 11 plus 2 mu, so 11 plus 2 mu. And I'm going to make lambda the subject, okay, so therefore if I take 2 from both sides, lambda will equal 9 plus 2 mu. And this is my second equation. Now I've got two equations with lambda and mu in, and I can solve these simultaneously. And it's up to you how you decide that you want to solve them. Okay, I'm going to use the substitution method. I'm going to substitute for lambda. I'm going to replace lambda in number 1 with 9 plus 2 mu. So what we'll do is we'll just come down here. Okay, it's going to be a bit of a tight squeeze, but we're going to sub, okay, equation 2 into 1. Alright, so we have 11 minus 2 times lambda. Lambda is 9 plus 2 mu, so I'll put that in brackets, 9 plus 2 mu. And that equals minus 5 minus 3 mu. So all we need to do is just clean this up, solve it for mu. So we've got 11 minus 2 nines are 18 minus 4 mu equals minus 5 minus 3 mu. And if I clean this up further, let's say we add 4 mu to both sides and add 5 to the left hand side. So we've got 11 minus 18 plus 5, that comes to minus 2. So we therefore have minus 2 equals, and we've got 4 mu minus 3 mu is mu. So therefore we've got mu equals minus 2. Now that we've got mu equals -2, we can get lambda by substituting it either into equation 1 or 2, but obviously 2 is the better one to substitute it into because it gives us lambda directly. So let's just say sub in 2, and if we do that, we therefore have that lambda equals 9 plus 2 times -2, 9 minus 4, that gives us lambda equals 5. Now all we need to do is to look at the k components, because if we look at the k components we can get what p is now, because we now know what lambda and mu are. If we look at the k components, we've got 17 plus lambda times -4, so therefore 17 plus lambda, which is 5, times -4 must equal p plus mu times 2, so that's p plus mu, which is -2, times 2. -2 times 2. If we work this out, 17 minus 20, that leaves us with -3. And on the right here we've got p, and then -2 times 2, well that's -4. And if we add 4 to both sides, we end up with 4 take 3, which is 1, and that equals p. So therefore p is equal to 1.